All right, let's hear. You had some questions about the Monday and Tuesday homework problems numbers 42, 45, and 48. Before I get started on going over those actual problems, we want to make sure that you understand the two things you're being asked to do in all three of those problems. The first, write a recursive formula. The second, write an explicit formula. Both provide you different things and both look differently when doing them. The first one is the recursive formula. If you notice right here, I write that you use it to find all terms given the starting value. And a recursive formula has two parts to it. It has the initial value of the sequence or the series of numbers that you were given, and which is known as A sub 1. And it also has a second part to it, which is the actual recursive formula. So when writing it, specifically for this section, which is on arithmetic sequences, which means the numbers go up by a positive or negative amount, constant number. To write a recursive formula, we write A sub 1, which means it's the first term in the number of series that you're given. It's the beginning of the list of numbers. And in that, we write whatever that number is, and we'll call it A right now. And then the recursive formula is A sub n. It always starts this way, and then it's always written this way next. A sub n minus 1, which this represents the previous term. So it says take the next term, and then I'm going to take that term and I'm going to add d, which d is the common difference, which is the difference between the numbers in the sets. And so you have to find that value out and you'll plug it in here. So in the next few minutes, we'll do these three questions here, and I'm going to write a recursive formula, and it must have these two parts. It's a common mistake when we go to assess this on a test. Kids forget that there's always the initial value and then the recursive formula. Now, an explicit formula allows you to find any number in the sequence. So I can say, hey, find the 100th term, the 100th number in the list, and it can jump straight to that value. And so the explicit formula allows you to pick any specific number in the series, and you can find it right away without having to find all the previous numbers before it. So it's just a faster way to find things. Now, the explicit definition is the same for all arithmetic sequences, and it looks like this. A sub n equals A plus, in parentheses, n minus 1 times the difference. Again, the difference is the number, the value between each term. We generally have to write this and tell us that n, the value of the term, needs to be greater than or equal to 1. And so when I go to give a test on this, I generally don't necessarily require you to write that down, but it's something to know that you can't go backwards in your series. So if I start my number at 4, you can't find numbers before it because I'm not asking you to do that. I'm only asking you to start with the number 4 and work your way to the right. So anyway, this is the explicit formula that allows you to find everything you need. And just remember that A in this spot here is your initial value. Okay, so hopefully that makes sense a little bit there. If not, let me know. But let's start with number 42. Okay, so you're being asked to write both of these two things here, an explicit formula and a recursive formula. And here is the sequence. So they give you the following numbers: 0, 6, 12, 18, and 24. And then they put a comment ... to tell you, hey, that this thing can go on forever. So right now, this would be my first term, second term, third term, fourth term, fifth term. And I can say later on, hey, given this sequence here, I want you to find the 100th term. So you have two options. You can find out the next 95 terms until you get 100, or you can jump straight to the 100th term using the explicit formula. So that's the benefit of that one there. So to write a recursive formula, I need to find the differences between these two. So I take the second term, I go 6 minus the first term. Sorry, forgot to move over there. 6 minus 0, and I get 6. I take the third term, 12, and I minus the term before it, and I get 6. I take the fourth term, and right now what I'm checking to see is it constant? Is it changing by each number by same value? So if I go 18 minus 12, if you notice, the differences are 6. So 6 is my D, okay, my common difference. So now I'm going to write my recursive formula. And if you remember up here, the recursive formula requires the initial value. So I write a sub 1 equals, and my first term is 0. Down below it, I literally just write this out just as it is, and the only part I fill in is D. So let me focus this a little bit better. So then I can write a sub n equals a sub n minus 1 plus 6, which is my D. I've now written a recursive formula for this sequence. So not too much there. Now I'll put an R here to remind me that this is my recursive formula. I now need to write my explicit formula. Okay, and again, the explicit formula is just this. Nothing changes except the D and the A. So I write a sub n equals, and if you remember, A is my initial value, or my first value of this sequence. So the first value of this sequence is 0. So I put a 0 there, plus, in parentheses, n minus 1. And then at the end, I put D, whatever D is. And in this case, we know that D is 6. So I put a 6. And then again, we usually write the n is greater than or equal to 1 also included. So these are the two different answers you're being asked to find: the recursive formula and the explicit formula. Okay. Now, again, now I can use this one. If I say I want you to find what would have been the 100th term of this, well, I would come over here. If I wanted to use it, here's an example. And I want you to find a sub 100. So then I would go, my initial term is 0 plus, well, n is 100. So right here I'd put 100 minus 1. And we know 6 is my difference. And so then if I wanted to find the 100th term, I would just do this math. I'd get 0. So 100 minus 1 is 99. So I'm really getting 0 plus 99 times 6. And then I would calculate that. And I get 594. So later on, the explicit formula comes in handy. So then I can ask you to find any number in this series. So if I kept finding all the numbers, and once I find the 100th number, that should be the answer. Hopefully that helps you find 45 and 48. You would do it the same way. If you have any questions with 45 and 48, you can. In fact, I'll start off number 45. 45 is a little tricky because it's got some negative values in there. But for 45, here's the sequence. You have -5, -3.5, comma, -2, and -0.5, comma 1, comma, dot, dot, dot. So first thing I do is I find my common difference. So I take the first term, or the second term, and I'm going to subtract the first term. Notice I put parentheses around it because we're minusing a -5. Well, when I do that, I get 1.5 for my difference. So let's check the next term to see if this is arithmetic. Again, the recursive formula and the explicit formula I showed you on the previous page only works when the numbers go up by a constant or they go down by a constant. So you can do addition or subtraction for arithmetic. So now I take the third term, -2, minus the second term, -3.5. And when I do the math, I get 1.5. So as you can tell, if I continue this with the remaining portions, I can find out that the differences between each number is they're going up by 1.5, or you can say going down by 1.5, depending on the type of problem you have here. But D is 1.5. So now use D to plug it into these equations right here. This D will go right there. Your initial value, -5, will go right there. And then this D will go right here. And -5 will go right there. So that should help you out a little bit. If you have any questions, man, keep sending me emails. Thanks. Bye.